morning, everybody. Thanks for inviting me here today. Yes, so really I still stick to it. Never say no to a customer, just tell them what it costs, like nothing. You can use MySQL free of charge, you can use Eucalyptus free of charge. I don't know why I don't learn. I love open source, but I also love building business around open source, because I feel that those who develop open source should get the benefit of that thing they are building. And that has sometimes made me a little bit controversial, because I'm ready to look for the business model that really gives money to the software developers, not the adjacent hardware developers. And that's a tricky thing. I won't be talking about it today. Today I'm here to talk about cloud computing. And I gave my speech the title, Open Skies, Open Clouds, because I will talk about clouds and the openness of them. But I somehow have a feeling that it's not just the clouds that need to be open, it is the skies where the clouds are. Meaning, you need openness in moving from one cloud to the other. You need APIs, it's not just the cloud itself, it is the environment where the cloud operates. So that's why open skies and open clouds. And then, of course, the skies weren't open, but we got this wonderful snow here, which I just love. You know, reminds me of my native Finland, which I haven't seen now in some time. But let me start with a question to you. In this audience, how many of you have used Amazon Web Services, AWS? Excellent, about half, good guess, yesterday. How many of you have tried out a private cloud solution? Okay, maybe a tenth. How many have tried Eucalyptus? Excellent, welcome, thank you, Juuso. So that's what this will be about today. Let's see here. But I was asked to first talk a little bit about the MySQL story. So I was the CEO of MySQL. I was the only CEO of MySQL. I joined in 2001 when the founders called me and said, Martin, we need a CEO and we think it's you. And I said, no. I'd known them since college times, and I don't think they knew anybody else who had ever been a CEO, and that was my qualification. I didn't know open source at the time. I did know databases a little bit. But we started building out MySQL with a very specific plan to sort of ride on the big open source movement back then. And 10 years ago, open source was a big, big thing. We were on the front page of Fortune magazine. Linus Torvalds and me were standing there in our bare feet on his front yard. So it was a big, big thing then. But have you noticed, it's not a big thing anymore. Open source is now so commonplace that Oracle has open source and Microsoft and everybody, so it's not a differentiator. But back then it was. So we built it on open source and we built it on disruption. We went out to disrupt Oracle. Of course, we had no chance of disrupting Oracle, and we were maybe 1,000th of the size. But every time when we positioned ourselves against Oracle, and it always worked. And every time Oracle was silent with us, it was good for us because it was sort of a silent approval. If they said something positive about us, it was good for us because it was a positive endorsement. And if they said something negative about us, it was even better. So when MySQL announced MySQL Cluster in 2004, Oracle immediately got an interview with eWeek where they listed 7 reasons why MySQL Cluster was not a threat to Oracle RAC. We loved it. That was our product roadmap for the next few years. Because Oracle told us what we needed to do to compete with them. And no wonder then that Oracle had to acquire Sun, which had acquired MySQL, because they needed to own MySQL. And now they acquired RightNow just a few days ago, and RightNow always said that they are an Oracle-free deployment. RightNow runs completely on MySQL. Now when Oracle owns MySQL, they can also own advanced companies like RightNow. So it really turned out nicely, but of course every success has a lot of dirty secrets inside, and the sausage factory looks like a sausage factory inside. I won't go into that, but it's a beautiful story, but there were many times when we thought MySQL would just go away or die or we would fail. One weakness we had that became a strength was that the MySQL database never was capable of scaling up. Meaning, if you put bigger hardware under it, it didn't perform any better. It didn't give you the benefit of big hardware. So we had to learn to scale out. We built out replication and sharding and all those techniques for how to run effectively on many pieces of cheap hardware rather than one piece of expensive hardware. And everybody laughed at us and felt that we were inferior because of this, like the Postgres guys. The Postgres guys always said, well, maybe you have the brand, but we have the product. And I said, that's fine. If I have to choose, I'd rather take the brand than the product. But anyhow, the fact that we developed the scale-out is what actually now is the big reason for success of MySQL. It's practically the only relational database that survives into the cloud times. Because in cloud, everything must scale out. And this is the beauty, but also the difficulty of cloud deployments. Everything is sliced into small pieces that need to run on identical pieces of hardware or identical virtual machines or identical instances. And your application and your database has to learn how to live in such a scale-out environment. And MySQL does it. And that's why today so much of cloud deployments are MySQL-based and not based on Oracle or IBM or Microsoft. So that's the story about MySQL. Now, as I'm CEO of Eucalyptus, it is an open source company in a similar way. But whereas MySQL was a disruptor of the old, Eucalyptus is an innovator of the new. Eucalyptus was the first private cloud software platform in the world. And those researchers who started it were just innovating new stuff that nobody had built before. But let's go into that. So, and talk about clouds. When people ask me what it is that really drives the transition to cloud, I happen to believe that it is the explosion on the mobile side. There are people who have estimated that we will soon have 1 trillion connected devices. And today we have a little bit less than 10 billion. And don't ask me how many, maybe 6, 7, or 8 billion. But people are saying we'll get to 1 trillion with all the gas meters, vehicles, medical devices, asterisk deployments, phones, iPads, iPods, everything. Everything will have an internet address and everything will be connected. And these devices, many of which are used by other devices, display unpredictable variable workloads. Your Kindle wakes up at times and checks for new updates, and then it doesn't do anything. And the only way to serve such an unpredictable variable workload is through cloud computing, where you can deploy compute cycles and pull them back when you don't need them. This is why I think we must go cloud. Otherwise, we'll have to fill the whole planet with servers if we continue to have dedicated servers for every need we have. We need to share the workload, and cloud computing is the only way to do it. And we will have public clouds, we'll have private clouds, on-premise clouds, virtual private clouds, government clouds, personal clouds. We'll have all types of clouds. Right now, Amazon is the leader here. Amazon Web Services probably has 90% of the public cloud market. Huge dominance in that market. But it will change over time, and there will be many, many, many other players. So that's why at University of California, Santa Barbara, 6 smart PhDs came up with something that they called an elastic utility computing architecture, linking your programs to useful systems. That's it. Could you repeat that? So if you wondered if there's a research background here, yes, there is, and this proves it. It was an NSF-funded project at UCSB in 2007. 2009, it got spun out as a company. I joined a year ago when we were about 15 in the company, and now we're getting close to 100 employees at Eucalyptus. So we are the world's most widely deployed private cloud software platform. So what Eucalyptus does is it gives you an AWS-like cloud on your own servers. And this is the unusual thing with our software. Most people have just learned that cloud means that you have no hardware, everything is out there. And then we come and say, no, you can have it. You can do it at home. We are the doggy bag. If you want to bring it home, if you want to bring the same experience home, take our software, install it on your servers, on your storage, and you have a cloud of your own that exposes the exact same API, the EC2, the S3, and EBS. So you can run a cloud inside your firewall. You can tune it, configure it, it's yours. It's your own cloud. That's why we call it private cloud. A more accurate description would be on-premise cloud, but most people call it private cloud. And when people install it, they can optionally click on a web link to find new images at Eucalyptus, and we see all those clicks In 2010, we saw 25,000 such clicks. So last year, 25,000 Eucalyptus clouds were spun up all over the world. And that's how we know we are the world's most widely deployed. Plinga is a gaming site, one of the leading social gaming sites in the world. They run some of their games on AWS, some of them on Eucalyptus. It's the same API, so they can freely move them back and forth. That's a hybrid cloud solution. USDA here in Colorado developed an application that serves farmers with information about rainfall and snowfall and irrigation, and they get it out on their smartphones, and it runs on Eucalyptus. And if you go to puma.com, you hit on Eucalyptus. They run all their websites and mini websites on Eucalyptus. And why do they do it? Well, to get elasticity. They never know which campaign will be popular, but they have enough servers to serve them all. They just don't know where they will need them. With Eucalyptus, they can shift around the workload, spin up machines for one website and spin them down from another. And here are a few more of our customers that we have today. Typically, technology companies, big brand owners, government agencies, NASA, NSA, USDA, FDA, and so on. So this is how we see the market. This is a sort of a market-centric slide. We have a private cloud software platform. I think the world now agrees that we will need private clouds. The public clouds will be massive, but many people will choose private clouds for reasons of security or compliance or control or governance or finances or latency or performance or whatever your reason is. We don't ask you why you need a private cloud. We just know that many do. And if you have a private cloud, you will at some point have a hybrid cloud. You will share some workload with another cloud. And there's a million of opportunities to build hybrid clouds. The most common people imagine is cloud bursting, where you have your application here, and then if it needs more scale, it goes out and takes resources from others. It may not be the biggest or first hybrid solution. We see others where people develop on Amazon and launch on Eucalyptus, or develop on Eucalyptus and launch on Amazon, or they have two Eucalyptus clouds that share resources, and many combinations. But the interesting thing we see here in the world is that people come from two different directions into private cloud. Some, like half of you, have experience with AWS, and you come to us and say, I love Amazon, but here's something I must run in-house. Maybe it's a big data application, and there's just no way we could move that much data out in the public cloud. So you come from the public cloud experience into the private cloud, and typically it's from an Amazon experience. But then there's the other side, the sysadmins and the DevOps guys who run huge data centers, and they come to us and say, we have been virtualizing our environment, we are done with that, now we are ready for the next step, which is going all the way to cloud. We need a cloud platform. And those people are typically VMware users, KVM, Xen users, sort of sysadmins and data center people who come in from that side, and they both end up with private clouds. So technically, the stages to cloud, this is how I explain it to my own limited brain. Our PhDs have much more elaborate information about this. But basically, you could say that traditionally, data centers were physically provisioned. You had one server running one set of middleware, one application. And still today, if you go into a data center, people will say, here's our website, here's our reporting, here's our bookkeeping, here's our HR system, here's the machines for the test team and the development team. So they're physically provisioned. But then came a time when servers became so powerful that any given server, even a sort of a cheap x86 thing, had more power than any application needed. So smart people invented virtualization, by which you split a machine into multiple pieces. So roughly, on average, people do, say, 10 VMs for a physical machine. So one physical machine suddenly is 10 virtual machines, and you can run 10 different applications on it. So that's, of course, a huge benefit, and that's why VMware is so successful, and why KVM and Xen and Hyper-V are so successful, because you get higher utilization. But you're still just splitting up your server into smaller pieces. The next step, and the final step, is to go all the way to cloud and tie them back together. And so you add a cloud platform on top of this, and you see now that cloud platform is maybe the first serious mission-critical software that we have developed in the stack, which by definition is multi-machine. It is by definition distributed computing. A hypervisor runs within one single machine. It's a very advanced piece of software, but it's in a single environment. A cloud platform like Eucalyptus or any of the others that are out there have to operate across many machines to even make sense. So it's a new challenge for developers, and that's why it emerged from a place like UCSB, which specializes in distributed computing. So that's what the cloud platform does. So it brings everything together and abstracts away the compute cycles. So a platform like Eucalyptus is then sitting there saying, okay, I have compute cycles, I have storage, and I have network. You tell me how much you need, when you need it, and I'll provide it to you. You don't need to, you as the application, you don't need to know which server it's running on. You don't need to know where it comes from. You just request and we will provide. This is the notion in our name of linking your programs to useful systems in the Eucalyptus name. So that's what the cloud platform does. And this means it's a new layer in the stack. It's a new piece of software. It's a new category. And then people say, why? We just got used to the LAMP stack and we have our data center full of software. Why do we need yet another layer? And the reason there is that with a cloud platform, you can orchestrate across all servers. You can provision dynamically. And we have seen telecom equipment manufacturer spin up an SMSC, a short message center, in 3 minutes, when usually it takes 3 months when a carrier orders a new SMSC to get it up and running. And they did it in 3 minutes because they had a cloud platform. So people do it for the agility, for the opportunity to just spin up things very, very fast. And I don't know if you work for big companies, but it can, if you request a new server, it can take 3 months, 6 months, 9 months to get a new server provisioned. I don't know where you stand today, but it just takes months. With a cloud platform, it takes minutes. And you can even do it through a self-provisioning portal. So it's just amazing agility, and you can go out much faster, go to market much faster. That's the first reason. The long-term reason is the bottom bullet point there, which is higher utilization. When you have a cloud platform that can share the load and give it to whoever needs it, you can increase utilization of your compute resources. And today on this planet, the average utilization of all our computers is, I don't know, 10%, 15%. It's very, very low. Most CPUs are just sitting there idling all the time. And with cloud, you can go much higher there. So that's the long-term benefit. But like I said, short-term is agility, then automation, the fact that you can manage your data center more easily because they are all the same sort of units that you can manage. And then elasticity, the ability to scale out and scale in. So when you have a sudden peak in workload, you can add more VMs, and when it stops, you can remove them. And that's very difficult today. When I explain this to people who are not in the software business, they say, shouldn't computers always have done this? And I agree, they should always have done this. We just didn't get there until now. So, but then I get back to these open sky things that when I think about cloud, I realize that it's changing the way we see the world. And many of us are used to the LAMP stack and variations of the LAMP stack, maybe the LAMP stack with asterisk. And it's a fixed stack. There's one operating system, one Apache, one MySQL, one PHP, Perl or Python, one of everything, and they are neatly stacked on top of each other. But in the cloud, stacks don't apply in the same way anymore. And we see how this changes the way we work on things. And what previously was a stack now is a set of APIs. All the components in the cloud need an API because we combine them in different ways. When I joined MySQL in 2001, we had to get into the Red Hat distro and the SUSE distro because the Linux distro was the place where everybody gathered, the place where software was distributed and used. Everything was about the Linux distro. Today, the Linux distro don't have that meaning anymore. You go to Amazon and there are 8,000 images that you can use. 8,000 distros, so to speak, because people have combined different pieces of software, and it may not be a LAMP stack. There may be MySQL, and there may be MongoDB, and there may be Memcached, all in the same place, and a little bit of Sphinx search engine and whatnot. So you get these sets of software that are more like, the only word I come up with is ensembles, and it's maybe a silly word, so please help me here. But they are not stacks, they're just tied together in different ways. And you as users you don't just take a distro. You take a Linux, you take some other things, you take some image templates, and you create your own images, you upload them to your cloud, to Amazon or some other cloud, and then you share them and you keep track of them, and the world just is different. And because of this, you must have APIs for everything. Everything must have an API. Even human beings have APIs, which sort of the mechanical Turk demonstrates. And with APIs, we can dynamically combine software and get what we need for that very moment. And it didn't used to be like this. So then when you look at the APIs in the cloud, there's one de facto standard today, and that's the Amazon EC2, S3, and EBS. They are not formally approved standards, but it is the dominant way to deal with cloud. Amazon has 90% of the market. They have hundreds of thousands of users. They have thousands of software vendors who are making sure that their products run on Amazon. So that's one set of APIs. And there are others emerging, and I think we'll see that everything will have an API. If you use Puppet or Chef for configuration, it's sort of an API to configuring your compute resources. So then if we go into discussing openness in cloud and what it means, it's a complicated topic, and this is probably my most complicated slide for today. So bear with me as I explain what I'm trying to say here. But I grew up with MySQL thinking that, okay, source code needs to be open. That's open source, and that's all you need. We have the GPL license. MySQL is GPL, Linux is GPL, everything is fine. Well, in the cloud, all of that changes. So you read it from left to right, and those white words tell you what you are providing. So if you're a user, and all you do provide is usage, and everything else is handled by the cloud, then the example would be Google. You're using Google, you're providing your usage to them. You're providing your search words. And Google handles everything else. You don't need to worry about how it computes it, where it finds the information. You just type in a word, you type in Denver weather, and you get it back. So you provide usage to Google, and they give you back what you need. And funnily, they built a business around it, around such a trivial thing as the words I'm searching for. But here you could ask and say, what's the openness here? Should Google tell us all the search words? Can they use our usage any way they like, or do we own it? Is it Google's property to know what I'm searching every day? And we have no answer to that yet, because we didn't have a Richard Stallman in this particular part of the industry writing a GPL license. The next one is if you're a Facebook user, you provide usage, but you also provide data, because you enter the names of your friends. So you're pushing your own data into the cloud, and Facebook handles the rest. And again, the question comes up is, what does openness mean here? Do you have a right to withdraw your data from Facebook? Yeah, I guess you do. Is it your data? Is it theirs? Can they show your pictures to people you don't know? And again, it's not clear what open here really means. One more step, you may give usage data and logic. You're a Salesforce user. So you enter the names of your customers, but you also enter the rules for your business conduct. And imagine now, Salesforce.com has a lot of customers, and they've all codified their rules of business conduct. So Salesforce probably knows a lot about how businesses are being run all over the world. And again, the question is, what's the openness we should require there? I know that you can download your own data from Salesforce at any time, and I think it's fantastic. Because I do think that cloud vendors must operate like banks, meaning you always have the right to withdraw your funds. And the fact that you can do it means you will never do so. We go and take out all our money from the bank only if we think that the bank cannot give it to us. But as long as we trust them in the ability to pay back, we don't really need to withdraw the funds. So those are our SaaS examples. Then you go to the next level and say, okay, I'm providing my usage, my data, my logic, and an application. So I'm a user of a PaaS service like Cloud Foundry. So then again, a new level of cloud usage. And again, you can ask, what does openness here mean? Should the APIs be open? Or what should be open so I can move my Cloud Foundry application to something else, like Cloud Shift or Engine Yard? Then if you also provide your middleware, you provide your whole stack, then you are practically an AWS user, an Amazon user. They give you the simple compute resources, EC2, S3, and EBS, and you build everything on top of that, and everything is yours. You can always withdraw it. They built it on open source, but you are not beholden to them. If you need to take it out, you can. And finally, if you're really the hardcore guys who love to run your own stuff, then you are a private cloud user. You use Eucalyptus, and you even have your own hardware. And there again, it's easy to define what openness means, because openness means that Eucalyptus is open source code. You can download it, you can install it, you can modify it, you can redistribute it, and if you don't like it, you do whatever you do with it. It comes under the license. But as there are different degrees of cloud, there will be different definitions of open. And we haven't solved all those questions yet. We have only realized that everything is built on open source. So all these fantastic cloud services are built on Linux and KVM and Zen and MySQL and Eucalyptus and all those things. So the components are open source, but we don't know yet whether the delivery also will be open. So we need to realize that open relates not just to code as it used to. It also relates to data and to APIs. We need open data. We need the right to use the data and pull it back if we own it. And we need open APIs, meaning we need to be able to trust the APIs and be able to use them mechanically, like we do. With Twitter, there's an API that we can use. It doesn't cost anything. It's reasonably well-defined, reasonably stable, so you could call it an open API. And other services have the same. So the raw material in cloud is most definitely open source software, but we must make sure that the delivery condition also is open. We don't want to see cloud vendors who build everything on open source, but then they provide it to you under a closed governance where you actually are locked in or where you lose control over what is yours. So with that, I'll end here. In summary, I think cloud is driven by growth in connected devices, and what I didn't say, growth in data. Data is growing like crazy. This is why we see big data and Hadoop grow, although the relational database market is big and growing as well. All the new workloads are being deployed on clouds. I'm not sure we'll see much migration of old applications to the cloud, because on the cloud you must scale out. You cannot scale up. And most old applications are hardwired to scale up. And the problem will be the database that just doesn't know how to run on 2 or 3 VMs if it needs to. And customers are looking for flexibility and choice. So what we see in our market is they look for open source solutions, they look for industry standard APIs, and they want to run on any platform, any hypervisor, because they want to maintain the flexibility and freedom to mix and match whatever they have. And the question that I don't really have an answer to, so I'm throwing it to you as a question, is, but what does open mean in the cloud? What should be open, and how do we make it as open as it should be? And this is where I'm asking for your help in driving this initiative and answering the question and helping set a standard, because I think we need the world to be very open, and it happens only if we demand it and take concrete steps to get there. So with that, let me stop here. There's my email address, my Twitter handler, if you'd like to follow me on Twitter. And I'm lost now on timing. Do we have time for questions, or don't we? Okay, we have time for a few questions, so I'd be happy to take one. There's a question. The question was, can you run asterisk on Eucalyptus? I bet you can. Have I tried it? No. So Eucalyptus provides EC2, S3, and EBS APIs to the application above. So if you can run asterisk on Amazon, you can run it on Eucalyptus. Anything that runs on Amazon runs on Eucalyptus. How do we make money? Well, we haven't made much money yet. It's an open source platform. Anybody can download it, and so they do. They pay us nothing. Wet Paint in Seattle said, go away, we don't need your support or anything because your platform works well and it doesn't crash. But we do sell annual subscriptions like Red Hat does, and we have developed commercial plugins that we plug in on top of the platform. So for instance, we support in the open source version KVM and Zen, the open source hypervisors, but if you run on VMware, you've already paid millions to VMware. So we don't think it's wrong for us to ask for a small payment. So to support VMware's hypervisors, you need our commercial plugin, which you pay money for. Of course, it is open source, so you can develop your own VMware plugin and not pay us. So there's always a way around it, but we provide those commercial plugins for customers who need them. And we have customers who just tell us that this is so mission critical, there's no way they would run unsupported, which was a little bit different from MySQL. In MySQL, we got no mercy from the customers. There was one single customer who ever paid us money out of mercy. It was Craigslist, who sent us $10,000 saying, there's nothing we can buy there, but we love you guys, so here's $10,000. But other than that, I've learned in business that customers may love you, but they have no mercy with you. They don't feel they have to give you any money. Google didn't give much money to MySQL, and many others didn't. So yes, we sell annual subscriptions, and we have had phenomenal growth this year. This is the year when private cloud is taking off. There's a question. So the question was, Rackspace offers a private cloud where they manage it for you. We are not in that business. We are a thoroughbred software vendor. We develop software, we engage with the community, we provide the software to the world. We are not planning to host or provide anything. That's the business for other people. We do have some test clouds. So we have the Eucalyptus Partner Cloud, the Eucalyptus Community Cloud that you can use free of charge, but they are limited, and it's not our business. We think we have expertise in producing the best software in the world, delivering it, doing QA, release management, and those things, and we are not operators of facilities. But we could have a partner one day that does it, and we're already seeing it in Asia, and Singapore, and China, companies who take Eucalyptus, build out private clouds for their customers. And that's a great business. I invite you to run it as well, because we won't be doing it. Okay, one final question over there. So the question was, what open source license? It's GPL 3. Great, thanks everybody. Thank you, Mark.